Good morning, everybody, and welcome to episode 5 of Intro to Space. So, today I'm going to be talking about the geostationary orbit. So, these are satellites that are about 35,000 kilometers away from the Earth. They are very far and very big. And in this orbit region, the period of the satellite is equal to the rotation of the Earth. So, they always have a constant coverage of a particular area, and there are many of them. So in this image that is being shown, you can see there are three regions. So the blue region is the Leo region. The green is the medium Earth orbit, and the red is the geostationary orbit. And if you see carefully at the bottom, you can tell the distance between the moon and the Earth. That distance is around about 385,000 kilometers on average. And yeah. Now the geo region is actually quite, what would you say? It's actually quite packed. So looking at this region, this is the geo belt, as you can see in this image. The geo belt, as you can see, it's very packed. The space between in the belt is where there is no land mass. So there's no need to put a satellite there. But everywhere else, it's packed. And and there's sometimes more than one satellite in a particular place. So what happens is they are separated by a few degrees. That's why you see like a whole long line list of satellites over there. So now that you have a better understanding of the geo belt, so now the next two images I'm about to show you give you a sense of the coverage in case you didn't fully understand. So the first one shows the coverage and the period. So after 12 hours, you're still facing the same point. And after 24 hours, you're still facing the same point, or the same area. And in the next image, as you can see, it shows the satellite in geostationary orbit and the angle that it covers. So the land that it's basically looking at. As you can see, it doesn't quite cover the pole regions. So it's actually weaker there in those areas. And usually countries then do other different things to get a better signal in that area. Now, there are two very important applications that occur with these types of satellites. The first one is Earth observation, but they're more specifically for weather. So that's how we get our weather predictions. Usually they give about the best one is usually a 7-day weather forecast. Anything more is sort of pushing the limits because the weather changes quite often. In case you ever wanted to curse why the weather channel didn't predict the right weather for the day, it's quite hard to do. And we also do it for climate change. So if you see the effects of how the Earth has warmed up over a period of time, you can then see how it's affected different parts of the area that they're looking at. The second one is communications. So this is just sending information from one point to another. This covers quite a lot of things, and under communications, there are more sub-applications, should I say. So these can be telephone calls, in case you want to connect to someone from one side of the planet to another. Television, this is the most popular one. Digital satellite television is the big one here. This is where you can charge quite a lot of money. Radio, you can send radio, usually amateur radio quite works here. The same as your radio on your car, but that's a bit more terrestrial than satellite based. And internet access. So internet access is more to do with connecting to remote areas of a country. For like instance, Elon Musk is trying to bring internet access using satellites in the Leo. The only issue is that the antenna always has to track where the satellites are. I think he's signed for about 7,000 satellites to provide internet access, and so that's a bit of a it'll be a bit interesting to see how that goes, since he's already launched a few and I think he's in the beta version as we speak, or is about to go into the beta version. So the reason why we use these satellites for communication is because the dish, so the DSTV dish, which most of us have, always points to a particular part in the sky. It never moves, and that because it's always pointing towards a satellite that's in that region or area. And because it's moving at the same rate as us, means the antenna doesn't have to move. But if it was in Leo, the antenna would basically be moving or tracking when the next satellite comes through. Might be a connectivity issue there. So South Africa doesn't own a communication satellite. What we do is hire one, and it's quite expensive. It's about 600 million rand a year, increasing by about 14% per annum. So you can imagine there have been feasibility studies to try and see whether we should own one, but haven't really seen much of that as of yet. Two companies that actually rent them hire satellites. Essentially, technically, you're hiring the transponder on the satellite, and these two companies are MultiChoice and Centec. They hire their communications from Intelsat. That's this big satellite that is up there. In terms of size of the satellites, looking at this image, this is Terra Star 1. As you can see, the people at the bottom, and that's actually the size of the satellite. So this is the size of the satellite when it's in launch configuration. When it's not in launch configuration, the solar panels actually basically expand, and the satellite can actually be about 20 meters in length. South Africa also has funded a communication satellite, and looking at this image here, this is the New Dawn. So we actually funded with other partners to build this communication satellite for Africa. And that is the episode for today. Next week, I will be talking about the SKA, and how does that help us as a country move forward in terms of radio astronomy. Thank you.